Hey guys, good morning all. Just give me yes in the chat if you guys can hear me and see the sublime text. Quickly give me yes in the chat if everybody can hear me loud and clear and you guys can see the sublime text. Or if you can, cool. Let's quickly start with what you have discussed in the last class and then we'll start with today's class. Okay. In the last session, we have completed our linked list. All the questions related to linked list have been covered. Today we'll be starting with a new topic, which is sorting. Okay. So in the last class, we discussed the last three questions, which is based upon reversal of linked list. We also did one more question, which was rotate list, which we'll discuss now. So in terms of reversal of linked list, we talked about the stack-based solution. You can put the nodes in the stack, you can pop out, you can connect the pointer and connect the first head to be null. Okay. Second is, and which is the expected solution in the interviews, you can use three pointers with using constant space, big of one space. How does it work? We create three pointers. One we call as previous, pointing to null, current pointing to head, next pointing to null. While you iterate through the linked list, these four lines of code is something you need to take care of. And these four lines of code, and out of that, actually line number 2 is the one which actually does the reversal for a linked list. So whenever you find any variation of reversal of linked list, this four lines of code, you'll find it everywhere. Okay. So what do? We put next equal to current dot next. So we keep a track of the next node. Current dot next become previous. So that's where you're doing the actual reversal. You move previous to current and current to next. Okay. Let's go for a quick code. We define the three pointers here. These are the four lines of code I was talking about. While current is not equal to null, we did that errand to understand what is happening at every iteration step. Then you send the head equal to previous, and finally return the head. Time comp is big of one, space comp big of one. Then you move to question number 10, which is lead code 92, reverse linked list 2. The problem statement says you're given the head of a linked list. You're given two integers left and right, where there's the position of left and right. You need to reverse the nodes only in this left and right. You don't need to reverse before left. You don't need to reverse after right. Follow-up question, can you do it in one pass? Okay. So more or less the question is this: I need to reverse between left and right position. There is no changes in the head left -1 and right +1 tail. Okay. So first thing first, I need to reach to the left node. Then I need to apply the reversal logic from left to right. How would that work? I define a dummy node, just have a -1. This -1 is going to act as a delimiter. I use those four lines of code. First, I go to the left, then I use this four lines of code. I do the reversal logic, and finally, I'm written my answer to dummy.next. Why? Because I created -1 as a delimiter. We talked about each of these steps, what is happening at every step. Time complexity, big of n, space complexity, big of 1. So technically, big of left plus big of right minus left, so you can count as big of right. Then we move to next question, which is reverse nodes in K group. This is a good question. What you're given is you're given the linked list. You need to reverse the nodes of the list K at a time and then return the modified list. Okay. So if I have to return in a size of K, how do we work? Either I can reverse a complete list. If I have to reverse a complete list, I'll put a logic like this. While my current is not equal to null, you put this four lines of code. If I have to reverse in a size of K, I just need to add one more condition till my count is less than K and keep a counter here. So that way, whenever I reach at K, it will stop there. Okay. Once you reverse the first K nodes, now you have two options. If the number of pending nodes is less than K, means there's nothing left to reverse. If it is more than K, then I can recur on the same function. Okay. That's exactly what you're going to do is first condition here, I go to the count of K. If count becomes equal to K, in the else case, I don't need to do anything. But if count becomes equal to K, then I will recur for n minus K. Okay. And I'll keep a track of the counter here. Time const big of n, space const big of 1 in terms of extra space, int big of n in terms of recursion stack. Then we did one more question apart from the reversal, which we call as rotate list. You're given the head of a linked list, you need to rotate the list to the right by k places. Now, when you say right by k places, we have done a similar question in terms of rotate array. So in terms of rotate array, we talked about if we have to do right rotate or left rotate, my effective number of rotation will be k modulus equal to n. Okay. So for right shifting an array, we talked about three reversal. You reverse from begin to end, then you 0 to k, then k to n. In terms of left shift, you reverse from array to begin to end, then k to n, and then 0 to k. Okay. In terms of my array, I can do something like I plus k modulus n, right? So that I don't go index out of bound. But in case of linked list, that approach is not possible because there's nothing called indexing there. So if I have to right shift or left shift in a linked list, I need to go back, which I cannot go back in a single linked list. So if I have to go back in terms of rotation, either left rotate or right rotate, I need to find a way where I will be able to traverse back. The only way to traverse back is that I can make the linked list circular, so there is no back or front. So I'm always traveling right, but technically I'm going back as well. Okay. How do I make it circular? I just make connect tail dot next equal to head, so I can travel forward and I can still connect with the previous nodes. So we got two approaches. If I have to right shift, these are the steps, and if it is left shift, these are the steps. So we verified by right shifting. This question was right shifting, so we verified by right shifting, verified on this try run part. It looks good. Then we move on to the code, and here we implemented the code part of it. Time cops remains big of n, space remains big of 1. And these are the final summary in terms of linked list question. Three main categories: fast and slow pointers, either with a difference of k or a speed of x and 2x. Reversal, either complete or size group of k, and rotation, either left rotate or right rotate. Okay, that marked our end of linked list. And then today we are going to start with the next topic, which we call as sorting. But before that, quickly give me clear. If everybody clear with the revision, then we can start with today's session. All good? Cool. Yeah, go ahead. Difference between current equal to head, current dot next equal to head dot next, current dot value equal to head dot value. Pretty much you have given the answer itself in the question. See, when you say current equal to head, you are assigning the head node to current node. Okay. When you say current dot next equal to head dot next, whatever the next node is starting from head. So take an example. Let's say my current is 2, 3, 4, and my head is maybe 7, 8, 9, just to make it easy. The moment you say current equal to head, now my current will be pointing to 7, 8, 9. That is what it does. Okay. When you say current dot next equal to head dot next, I'll take this part. Current dot next equal to head dot next means my current is pointing at 2, current dot next will be 3. So you are saying 3 dot next should point to head dot next. So head dot next is pointing to 8. So my linked list would be 2, 3, 8, and 8 next is automatically 9. That is what it means. And when you say current dot value equal to head dot value, you are just replacing the value. Then nothing, reference will not change. As long as you're doing operation on value, nothing will change. But the moment you start doing operations on the node, that is when the reference would change. Okay. All right. Cool. How do you use the existing list object in Java? We create node object to represent linked list. How to use the existing linked list object in Java? When you say existing linked list object, what does that mean? There's a linked list class, if that's what you're referring to. There's no linked list object as such. Okay. Yes, you can do it. I mean, you can create like linked list. Java provides you a collection framework. Let's say linked list of integer ll equal to new linked list of integer. And on top of that collection framework, you can do ll.add whatever value you want and ll.remove. Okay, those things. But this pretty much will never be asked in the interview. In the interview, the question is you're given a structure of a node and you need to implement it. So there's no point of using collection framework. Okay, but to answer your question, yes, the collection framework provides a linked list interface, which is extended from list interface. Okay. All right, guys. If that is good, let's start with our new topic, which is sorting. Sorting will usually take 2 classes. So today class and maybe tomorrow class at max, we should be able to wrap this topic up. What is sorting? Let's start from the beginning. Sorting is an algorithm which is used to convert unsorted list of values, to sorted list of values. This is what you call a sort. So if I take an example, 316892, if I sort it by any algorithm, this is going to be 1, 2, 3, 6, 8, 9. Okay. Now, to implement the sort, there are multiple algorithms. We don't need to talk about every one of them, but I'm listing down some of the important algorithms that we can go one by one. So bubble sort being the easiest one, insertion sort, selection sort, merge sort, and quick sort. Okay. You don't need to go through the code of these sorting algorithms. I mean, you should know it, but it's not necessarily being very important from an interview perspective. Okay. That being said, there are 2 categories of question. If the question is about using sorting as an intermediate step, nobody wants you to write the code of this. You can simply do arrays.sort and you can continue to your next step if it is an intermediary step. But if the question itself is implement a bubble sort, implement a quick sort, implement a merge sort, then obviously they're looking for code of this one, which is not that common. I mean, it depends on organization to organization. But good product-based companies, they have much better questions to ask. So I personally don't think they would ask questions like that. They may or may not, depends on the interview, depends on the role. But I do not expect somebody to ask merge or write the code of merge sort with somebody with more than 5 years of experience. Okay. Anyways, out of this, implementation of this merge sort and quick sort is important. Some other algorithms apart from this, these are the common ones and important ones. Apart from this, we have heap sort, we have radix sort, we have count sort, and we have bucket sort. Okay. Now, before I move to the next part, let me ask you this question first. Can any one of you tell me which is the best sorting algorithm in the world? Come on, guys, look in the chat. Anyone can tell me the answer of this question, which is the best sorting algorithm in the world? Depends. Okay. Very classic answer. Merge sort. Okay. Quick sort. This is the question. Nothing else is mentioned. This is the question. Which is the best sorting algorithm in the world? However you want to define best. Quick sort, merge sort. Okay. Anybody else? Mixing of two best sorting algorithm like Tim sort. Okay. All right. Do one thing. Take this as a homework. Feel free to Google it. Feel free to read any books. Feel free to chat GPT. Feel free to do Claude. Whatever thing that you want to refer to. Okay. And remind me to discuss it tomorrow. Feel free to discuss or feel free to research whatever you want to, however you want to, totally up to you. Just let me know the answer of this question and remind me to discuss tomorrow. Okay, this is an interesting one to talk about. Anyways, let's continue with something and let's talk about inbuilt sort. Inbuilt sort means your languages, however you're implementing, they by default provides you some sorting functionality. Okay, so if I talk about Java, Java provides you arrays dot sort array. This is what Java provides you. Okay. Time complexity, space complexity of this code. Anybody? One line of code. What is time and space complexity of this? Correct. Time complexity is n log n. Space complexity. Correct. Big of one. Means it is not creating any additional array. It's implementing on the same array itself. This is what you call as in-place sorting. Okay. All right. C++ provides you something similar. C++ says sort array comma array plus n. Again, this is an in-place sorting and same time and space complexity. For Python, guys, there is something similar. You get sorted, whatever list or array you want to provide. Again, in place sorting. And this is time comps to big of n log n, space comp to big of 1. Okay. All right. Yeah, something similar in JavaScript. Pretty much every function, it's going to be n log n, space big of 1, every language. Now, here's my question. Let's say you have this word function. Somewhere using arrays.sort array and this. So imagine all the lines apart from this arrays.sort is big of 1 complexity. Imagine that. And there are 1,000 test cases, or maybe even more than that. What is time and space complexity of this code? Imagine everything else is big of 1, and this is also big of 1. What will be the time and space complexity? Okay, all agree? Cool. You say the time complexity is n log n, space complexity is big of 1. I'm not concerned about space, but let's talk about time complexity. Why did I ask this question is, when you say even with 1,000 test cases and whatever number of test cases, time complexity still remains big of n log n. Means out of these 1,000 test cases, there would be test cases which will be best case, there would be test case which will be average case, there would be test case which are worst case. Agree? When you have more data, like more in terms of sample test cases, some test case would be the worst case, some test case would be the best case, some test would be the average case. All agree with that? Come on, guys, click in the chat. Okay. That leads to me a very interesting finding, which is this STL in C++ or collection framework in Java or module in Python. The sorting which is provided by default, it is always is n-log. This word always is important. Irrespective of best case, worst case, average case. Best case, worst case, average case. Okay. Now, if everyone aligns with that, now that leads me to a question for Java developers, C++ developer, Python developers. Tell me which algorithm is this? Algorithm in the sense, which internal sorting algorithm it is. I don't want you to search it. If you know the answer, tell me. If you don't know the answer, completely fine. Think and tell me what is this sorting algorithm which always is working in n log n with a space complexity of big of 1. Let me know in the chat, then we'll discuss. 30 seconds for you guys, quick in the chat. Internally, what is the sorting algorithm implemented here? Quickly in the chat, guys. All right, guys. Anybody gave correct answers? Cool. Let's discuss it and let's try to get the answers. Some of you said quick sort, some of you said merge sort. These are the only answer I saw in the chat. Okay. Let's check both of them. We know quicksort best case complexity is n log n. Let's start with average, and then we'll go for worst. So quicksort best case complexity is n log n. Average case is also n log n. Worst case is big of n square. Okay. So one thing is clear. This cannot be quicksort. Why? Because here in the of all cases, be it best, be it average, be it worst, my complexity remains n log n. It never goes to n square. You will never say that my code will become n square if there are 20,000 test cases or 50,000 test cases as compared to 100 test cases. So complexity always remains big of n log n. So one thing is 100% clear. This is not just quicksort. All agree? Come on, guys, quick in the chat. In terms of time complexity, you can deduce if quicksort has the worst case of big of n square, but this code, even the worst case is n log n. One thing is 100% clear. This is not just quicksort. Okay, cool. Let's go to the second option. Second option, okay, one more thing to add, space complexity of quicksort is big of 1 in all cases, which is great. Space complexity is big of 1 in this case as well. Okay, but still time complexity is not matching, so it is not quicksort. Now let's talk about merge sort. Merge sort is n log n, n log n, and n log n, even in the worst case. So this is good. My time complexity is matching for sure, but merge sort has a space complexity of big of n. This code has a space complexity of big of 1. Even though my time complexity is matching in best case, worst case, average case, merge sort always take an extra space. This code does not take an extra space. This code implements on the same array. So 100% this is not merge sort either. All agree? Come on guys, quick in the chat. Neither it is completely quick sort, nor it is completely merge sort. Okay. So worst case of quick sort is not being used in STL collection framework module. Okay. In my STL or whatever you want to write here, my time complexity is big of n log n. My space complexity remains big of 1. Quick sort, my worst case becomes big of n square. Space complexity is big of 1. For at least one test case, quick sort must have worst case, which is big of n square. At least for one test case, it should have big of n square. So that makes it very clear it cannot be pure quicksort. Similarly, if I talk about merge sort here, even if I include the best and average worst case, because all of them are same, and into log n, space complexity is big of n. This is pretty much clear. My STL sorting does not only include merge sort. This part clear? Okay. So what do we get out of this? We understand this. The internal sorting or the inbuilt sorting that we're using, it is not pure quicksort. It is not pure merge sort. So what is happening behind the scenes? There is and must be some other sorting algorithm which is leading to time complexity of big of n log n in all cases and space complexity of big of 1. All agree with this. It's not pure quicksort, it's not pure merge sort. There is some other algorithm which is leading to n log n complexity in all cases, space complexity big of 1. All agree with this. Come on guys, quick in the chat. Cool. This is what we call as hybrid sorting. Okay. Hybrid sorting is nothing. It is combining multiple sorting algorithms together. That is what we call as hybrid sorting. Okay. The correct answer here is tim sort. Tim sort is used merge sort plus insertion sort. Okay. This is used in your arrays.sort and sorted list. Basically in Java and Python. So Java and Python, behind the scene, they use tim sort, which is a combination of merge sort and insertion sort. C++, when you write sort array from array plus array plus n, that is quick sort plus merge sort plus insertion sort. There is no name called Tim sort for it. We just call it as a combination of quick sort plus merge sort plus insertion sort. Here we have a specifically name. We call it as Tim sort. Okay. All right, guys. That was one thing important to clarify because we have been using this sorting logic, which is provided by different languages. Quite a lot of fun. And I'm pretty sure you would have used it at one point of time for sure. You should know what it internally using is. Okay. All right. If this is good, now we can start with this part. Okay. We'll take this sorting algorithm one by one. We'll try to understand everything, how they work in terms of details, in terms of logic. We'll move on to the code and then we'll talk about time and space complexity along with best case and worst case. We'll go to each one of them individually. So let's start with number one, which is the easiest one, which we call as bubble sort. Bubble sort is the simplest sorting algorithm. What is the approach of bubble sort? The approach of bubble sort is pretty clear. Bubble sort says swap adjacent elements if they are not in ascending order. Okay, let's talk about it. Bubble sort says swap the adjacent elements if they are not in ascending order. Okay, we are going to understand this by dry run, then we'll get to know. My array is, let's say, 5, 1, 4, 2, 8. So my output will be 1, 2, 4, 5, 8. Okay, let's talk about first iteration or pass. If I have 5, 1, 4, 2, 8, what did it say? Swap the adjacent elements if they're not in ascending order. So it's going to be I here, J here. Let's talk about the adjacent element from the beginning. So 5 and 1, do I need to swap? Swap or no swap? Come on guys, swap or no swap? Definitely swap because 5 is greater than 1. So it will become 1, 5, 4, 2, 8. 5 is greater than 1, hence it's going to be a swap. Easy. Let's copy this, paste it here. Now this has become 1, this has become 5. This will move here. And before we decide that, let's understand. 5 and 4, swap or no swap? Again, swap. 5 is greater than 4, hence swap. So this guy would become 4 and 5. Easy. Now come here. This has become 4, this has become 5. My pointers will move ahead. Now what? 5 and 2, swap or no swap? 5 is greater than 2. Of course, it is a swap, so it will become 2, 5. I'll copy this. I'll paste it here. 2, 5. Last is 5, 8. Swap or no swap? 5 is less than 8. This time, I don't need a swap. Oops, they got deleted. This time, I don't need a swap. Okay. So my array got 1, 4, 2, 5, 8. Okay. Is my array sorted now? No. So what we'll do, we'll go for second iteration. By the way, how would I get to know if my array is sorted? How would I get to know if my array is sorted? Well, I'll get to know my array is sorted if every iteration of this is no swap. Agree? If I don't need to swap anything, means they all are in the right places. That's how I'll get to know, at least from this algorithm perspective, that's how I'll get to know in terms of code that now it is sorted. Okay. So still there is still there is 3 swaps. So obviously it is not sorted. Okay. So I'll continue from here now. Now you got 1, 4, 2, 5, 8. Let's get back your I and J here. 1 and 4. 1 is less than 4. Swap or no swap? One less quick. No swap. Continue. Move on to next. Now your pointers will move here. 4 is greater than 2. Swap or no swap? Definitely a swap. So this will become 2. This will become 4. Move on. 4 is less than 5, swap or no swap? This will not be any swap, so let's put it as no swap. Move on, 5 and 8. Again, it's going to be no swap. Okay. Is my array sorted now? Is my array sorted now? At this moment itself, my array becomes sorted. Okay. But does my program know how to check it? No. I can say it's 1, 2, 4, 5, 8. I can say it's sorted, but my program does not know that. So what my program will do? My program will check for third iteration, which is not required, but it will still check for third iteration because till the part everything is a no swap, it will not agree to it. So copy this, we go to third iteration. This would be I comma j here. You will see 1 is less than 2, no swap. Continue, this will become ij. 2 less than 4, no swap. Continue. 4 less than 5, no swap. Continue. 5 less than 8, again no swap. Now your program will stop and it will get your array or list to be sorted. All agree with this? All agree with this iteration? So one thing that we have very clearly identified, I am doing one extra iteration. And when I say one extra iteration, we're talking about for each consecutive pair. So you can see it's a big of n square code, right? Even if I have not written the code, you can understand. I'm taking 2 pointers and 2 pointers at every step. I'm checking for all the values. So it's a big of n square code. It's taking one extra iteration just to confirm if everything is sorted. Technically, I got my sorted array here, but still it will continue to do one more iteration to confirm if the array is actually sorted. All agree? Someone guys speak in the chat. Okay. That being said, let's write down the code of it. We understood the approach. We can quickly write down the code for this. This is called bubble sort. What are you given? You're given the array. You're given the size of the array. Integer I equal to 0, I less than n, I plus plus, j equal to I plus 1, j less than n, j plus plus. If my array of I is greater than array of j, means they are not in ascending order. What do I need to do? I need to swap array of I to array of j. What will happen? My time complexity will hit big of n square. My space complexity will get big of 1. All agree with this? We'll come to it. All agree with this? One moment, guys. We'll come to this. I need to check for each and every pair. In that pair, I'll compare. If anything is not in ascending order, I'll continue swap. If it is in, then I don't do anything. Else condition is not required. Okay. Best case, I would need minimum swaps, means an already sorted array. Worst case, I would need the maximum swaps, means descending order. That's what that question you were asking. Okay. Complexity would be big of n square. Okay. My time complexity becomes big of n square. My space complexity remains big of 1. This is what bubble sort is. Everybody clear? Come on, guys, click in the chat. All clear? Cool. One more thing, all that's not important, but you should know it. Why does the name bubble sort? Why do we call it bubble sort? See, the approach of this algorithm is pretty clear, and this will be important once we talk about the insertion sort also. The name is called bubble sort because what you are doing as part of this algorithm, you are bubbling the utmost value or the highest value toward the end. Okay. You're bubbling the greater values. For example, if it was 5, 1, you made it 1, 5. If it was 5, 4, you make it 4, 5. So whatever the greater values, you're bubbling towards the end of the array. That is what is called bubble sorts. Okay. So my greater values are bubbled towards the end of an array. That's what is called bubble sort. Okay. Inner loop condition -1 will come. Inner loop condition -1 will come. Which condition? One moment, guys. Which line number you're referring to? Let me know. According to the loops, if I equal to 1 and j will go from 2 to n. Yes, 295 since I plus 1. -1 in what case exactly? Hey, you can adjust the pointers wherever j value is going for. Whatever the j value is going for, you can compare. Okay. I'm just telling about the logic here, how the logic would work. Okay. This will pick the ith element and compare with all other element in the array and completely adjacent elements. Will be 1, 2, 1, 3, 1, 4. No, you can break, right? What we're doing is we're just comparing between the one element consecutively. So that's what that's about the same question somebody asked. At one moment, we are comparing only one pair. Okay, so 0 index with 1 index, then 1 index with 2 index, 2 index with 3 index, so on and so forth. Okay, but you have to do multiple iterations. That's how you'll be doing it. Okay, you will not be comparing the 0 index with 4 index, just to be clear. Okay, all right. Should we check in function if there is any swap? Should we check in function if there is any swap happen for iteration? You can do the optimization on top of it, but still it's going to take you big of n square. The reason for that is until unless you don't get everything without no swap, it is not going to mark it as done. Okay. I mean, yes, you can keep a check, but it's the code will still remain big of n square because you have to run that one extra iteration. Okay. All right, guys. That was bubble sort, one of the easiest sorting algorithms. That's how it starts with. So just mark it as done. Let's take the next part, which is selection sort. Okay. Let's see what is selection sort, how does it work, so on and so forth. As the name says selection sort, you are going to select the smallest element in an array. You are going to place it at the beginning of array. And you're going to repeat the entire process for complete array, portion of array, and so on and so forth till last two elements in the array. Okay. This is what selection sort is. So pick up the smallest element, place it at the beginning of the array, and you have to repeat this process for complete array 1 to n till n minus 1 to n. Okay. So if we talk about dry run, my array is going to be 64, 25, 12, 22, 11, let's say. My expected output is 11, 12, 22, 25, 64. Okay. My indexing goes from 0 to 4. The array element size is 5, so it will be 0 to n minus 1. So it's going to be 0 to 4. Okay. So I'll start with step by step. Number 1, if I take array 0 to 4, 64, 25, 12, 22, 11. What does the code says? Pick the smallest element. So my smallest element is what? My smallest element is 11. Place it to the beginning. Okay. So if I take 0 to 4, the entire array, my smallest element is 11. I place it to the beginning. So this guy would get converted to 11, 64, 25, 12, and 22. All agree with this? Quick in the chat, guys. All agree? Okay. Number 2. Next, I need to continue till I become n minus 1 and n, basically till I reach to the last two elements of that array. Now I'll take 1 to 4, So 1 to 4, you're referring about 64 or 64, 25, 12, and 22. Correct. So in this case, what is the smallest element? What is the smallest element out of this? Smallest element is 12. I need to place it to the beginning. So this guy, if I place it to the beginning, this would become 12, 22, 25, 64. What next? Array of 2 to 4. So 2 to 4 will become 22, 25, 64. Same logic here. Smallest element, put it to the beginning. What are you going to do now? Smallest element is already at the beginning. So what will happen? This would become, or if I take the total array, this would become 11, 12, 22, 25, 64. This would remain 11, 12, 22, 25, 64. Okay. Let me see. 25, 12. Okay, did we miss something here? We got this. So this should be 12 and 64 and 22 and 25. Correct? This should be 64, 25, and 22. Okay. And after this, we should take it as what? 64, 25, and 22. So this should be 22, and you place it to the beginning. So 11, 12, 64, 25, 22 would be what? 22, 25, 64. Okay, now it's correct. All right, now what's the last part? Last part in terms of my array of 3 to 4, which is the last two values, which will be 64 and 25. I need to find the smallest element. I need to place it to the beginning. So smallest element is 25 here. I'll place it to the beginning. So this guy would get converted to 11, 12, 22, 25, and 64. Okay. This is what your final answer would be. Everybody clear? See how you're starting. We just did 4 iterations here. How you're starting is 11 is missing in second step. Okay, let me add the complete array. So we got 11 this. Let's add 11 this. Let's add 11 here. Okay. 1, 2, 3, 4, 5, 4, 5, 4, 5. Cool. Now, what are we doing here is we start with the entire array and we keep on dividing the array until we have the last two elements. Okay. We start with 0, 4, then 1, 4, then 2, 4, then 3, 4. Right. So you can understand whatever the size of the array n minus 1 number of times this code will run. So the size is 5. So we have to run n minus 1, which is 5 minus 1, 4 times. What are we doing at every iteration? What we're doing at every iteration is we pick up the smallest element and we place it to the beginning. So in this case, if I talk about 0 to 4, which is the complete array, smallest element is 11, I put it to the beginning. Then in terms of 1 to 4, so I just highlighted this 1 to 4, we take the smallest element, put it to the beginning. So this 11 was already there. I will not change the position. I will only change the position in this case. Then you talk about 22. At least in this case, from 2 to 4, the smallest element is 22. So these two will not change anyways. Whatever change will happen in the size of 3. And here also the change will happen in the size of 2. So that's where you got the output. Okay. Everybody clear so far? Cool. Now selection sort is, are we shifting remaining elements? No, we are not changing remaining elements. Remaining element will remain as it is. Okay. Selection sort is pretty much opposite of bubble sort. Why I'm using the word opposite here? Let's talk about it in terms of my approach wise. What we were doing in terms of bubble sort, we were taking the largest element, we were putting it to the right side. In terms of selection sort, we're putting the smallest element and we're putting into the left side. So in approach wise, it's exactly opposite of bubble sort. Time comes to remain the same, big of n square in worst case, space promptly big of r. Okay. Everybody crystal clear with this? Bubble sort and selection sort, quick in the chat. Everybody crystal clear? Okay, cool. Now let's start with some lead code questions. I'll continue with quicksort and merge sort, but I don't just want to make this class just completely theory. So let's start with some lead code question. The first question is very important. A lot of variation have been asked in a lot of good companies. We are going to check it right away. The question is kth largest element in an array. Okay. So let me open this problem statement. Then we can go really quick over it. All right, lead code is opening up. All right, let me change the code real quick. There you go. Cool. This is the function that we need to solve for. This is lead code medium, and as you can see, 17.9 thousand likes, and even more important, 4.5 million submissions. This is a very important question which has been asked in a lot of companies, very recently in a lot of companies. Okay. All those good product-based companies, let's have a look at the question. The question says you're given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay. Can you solve it without sorting? That's a follow-up question. You're given some values and we're given some constraint. K is less than nums dot length up to 10 to the power 5 and nums value between minus 10,000 to plus 10,000. Whenever you see this kind of a code or this kind of a constraint, what is the worst complexity you can solve? 10 to the power 4, what is the worst complexity my code will pass or test case? Click in the chat. Come on guys, we have gone through multiple times. Correct. It's big of n square. Let's take this part. Let's bring it here. Let's go to Sublime. Let's talk about it here. And let's get the link of the problem statement as well, so we can do it really quick. Okay. The function that we need to complete, let me write it down, then we can talk about it one by one. This is the function that we need to complete. We are given the function find kth largest, which is returning an integer, taking an integer array and an integer k. Okay. Before we jump to the solution part, let's make sure we are crystal clear with the understanding. Again, I'm repeating, this is important from interview perspective. It has been asked a lot of times in really good product-based companies. Okay. Understanding is, if I'm given given some test case, let's take this test case, 321,654. One moment. 10 to the power 4 square root 10 to the power 8 will not work. No, 10 to the power 4 will work because up to 10 to the power 8 we can do. More than 10 to the power 8 we cannot. Then it will give you TLE. Okay. So if you have k equal to 2, if I make a sorted order out of it, sorted order will become 1, 2, 3, 4, 5, 6. My first largest element is what? My first largest element is 6. And my second largest element is what? It is 5, which is k equal to 2, which is the answer. Okay. Now, obviously, whenever you're solving this question, be clear. If the question is kth largest element, in interview, they will not ask you the exact question. They'll ask a variation of it. They might ask you what is the index of the kth largest element, or they might ask you kth smallest element, right? So when you're solving this question, be also well prepared with the variations of the question which could be asked. It hardly takes 1 or 2 line of code changes. Okay. Anyways, coming back to it. So this is what k equal to 2 answer. Let's take one more test, please. This guy, let's talk about it. If I talk about sorted order of this, I will get 1, 2, 2, 3, 3, 4, 5, 5, 6. Okay. Now, first largest element, is 6. Second largest element, is 5. Third largest element. Which is the third largest element? Quickly in the chat. This is where it becomes interesting. The question said kth largest element in the sorted order, not the kth distinct element. If the question was find me the kth distinct largest element, that's a separate thing. Okay. In that case, my third largest element would become 4 here, right? But my question did not say distinct. So my third largest element will still remain 5. All clear with this? So variation of this question could be kth distinct largest element. That's how you make the variations of the question. That's it. See, pretty much every time you're solving a question is either the exact question or a variation of a question. You can make thousands of variation of a question by changing few constant. That's how the interview questions are made. Okay. All right. Coming to fourth largest element. Let me mention our statement here. If third largest unique element, in that case, my answer would be 4. Now, fourth largest element, that is going to be 4. And that is what your answer is. Your answer was 4 here. There you go. I believe now everyone should be crystal clear with the problem statement. You're given an array, you just need to find kth largest element in it. One way is definitely yes, you can go ahead with sorting. They ask a follow-up question, can you solve it without sorting? Everybody crystal clear with the problem statement. Any doubts, any questions, any follow-ups, please let me know. All good? Cool. If all good, you guys know the drill. This is your read code problem statement. This is the function that you need to complete. Feel free to go ahead, implement in the language of your choice. Once you guys are done, share the submission link with me, change your message directly to me. Do not message to everyone. Okay. Up to you guys now. Whenever you're done, please let me know. Then we can start the discussion. Your time starts now. All guys, good to discuss. Anyone needs more time? Good to discuss. Okay. All good. Shall I discuss the answer? Cool. All right. Looking at the constant 10 to the power 5. If it is 10 to the power, not 10 to the power 5. If you're doing 10 to the power 5, big O n square code will not pass. Okay. The constant is based upon the length, not actually the value of the array. So 10 to the power 5, if you're writing a code something of big of n square, probably you will get a TLE. So those who have written that, please check your code. Okay. Anyways, let's start with the solution. This question is quite important in the context of two reasons. One, there's a straightforward approach, which we call as brute force. And second is the optimal solution. And when you apply the optimal solution, there is a new concept of a data structure, which we are going to learn about, which we call as heap. Okay. It's completely fine if you don't know what is a heap. We are going to discuss that from scratch. Okay. But let's start with the brute force ones. First thing first, what I can do is I can do ascending sorting. Ascending sorting means, let's take this guy, put it here. After sorting, what will happen? After sorting, you will have 1, 2, 3, 4, 5, 6, n equal to 6, you need k equal to 2. After the sixth element, you need the second largest element. So my index would become n minus k, that would become 6 minus 2, that would become 4. So 0, 1, 2, 3, 4. So n minus k plus 1, you can write it. And you can give the output here as 5. So answer would become array of n minus k. Time constant would become big of n log n. Space constant would become big of 1. I can simply write ascending sort, which is arrays.sort. I can get array of n minus k. Sorting will take me n log n complexity. This code will take me big of 1. So my total complexity becomes n log n space big of 1. All agree with this? All agree with this? Quick in the chat. Okay. Number 2, just an optimization on that. If I'm sorting the entire array, instead of doing ascending sort, I can easily do descending sort also. Okay. What do you mean by descending sort? Same logic. The values will change now. After descending sort, this will become reverse. So this will become 6, 5, 4, 3, 2, 1. Okay. This is what you become a descending sort, basically in decreasing order. So my index would become k minus 1 and my answer would be array of k minus 1. Okay. Time complexity becomes big of n log n, space complexity becomes big of 1. All agree with this? Time complexity becomes n log n, space complexity becomes big of 1. Now, doesn't make any difference in the complexity, to be honest. Either you do ascending sort or descending sort. The difference is only in terms of whether you're doing n minus k or k minus 1, which both of them are big of 1 function. How do you do descending sort? Let me tell you those as well. In C++, you are just going to write, this is what you write for sorting in ascending sort. Array.begin, array.end. Just use this part, greater of integer. It will do the reverse of it. Okay. This will work as descending sort. In case of Java, you type arrays.sort array. This will do the ascending sort. If you add reverse starting index and ending index till wherever you want to reverse it, that will get you descending sort. Okay, just now talk about the syntax. And of course, it's an in-place solution. This is brute force approach. These two are the brute force solution for this question. The question itself says, can you solve it without sorting? Everybody clear with the sorting solution? I talked about both ascending and descending. All clear? N log n complexity, space big of 1. These are the brute force solution. This is not something interviewers are looking for, just to be clear, right? What interviewers are looking for is a more optimal solution. So what is a more optimal solution here? The optimal solutions here is using a heap. Either use a max heap or use a min heap. Okay, we'll talk about it one by one. If you're using a max heap, my largest element is at the root. That's straightforward. I need to pop for k minus 1 times. Then my root will be pointing at kth largest element. Okay. For a min heap, my smallest element is at the root. I need to pop n minus k times. Okay. Let's take a step moment and try to understand what exactly is a heap as data structure. Then we'll talk about max heap and min heap and those kind of things. Okay. So if I have an array like 1, 5, and 2, we'll start with 3 elements. What exactly is a heap? Let's try to understand this. Heap or priority queue, whatever you want to call it. Minimum priority queue or maximum priority queue or min heap or max heap. What exactly is a heap? Heap is simply just a binary tree. Okay, to understand this, what exactly makes a structure of a heap? A heap is nothing, a heap is just a binary tree. Okay, how it's different from binary tree or what exact formation of binary tree is that is? It has the capability that it can reshuffle. It can reshuffle the value, it can reshuffle the nodes. That is something which we call as heapify function. So whenever you insert anything, whenever you delete anything, the values will reshuffle itself. That's what you call it as heapify function. Now, how does that work? Let's go one by one. If I'm talking about, let's say, a max heap, so I will say max heap here, and then we'll talk about min heap. So in terms of a max heap, my largest element will stay at the root. So I got first element, that is the largest, so that is my root. It is 1 here. Okay. Everybody clear so far? I got one element, I inserted one element that is at the root, that is the largest. All agree? Quick in the chat, guys. Guys, be quick. Heap is an important data structure. Okay. Now, next one. Next one is, okay, explaining it. Think of just like a binary tree. How does a binary tree looks like? There is a root, there is children, there is children, then this has children, this has children, this has children, this has children. Okay. This is what heap is. Simple binary tree. The only thing with heap is heap has the capability that it can reshuffle the nodes. This value can become here, this value can go here, this value can go here, this value can go here. That is the only capability of a heap. Apart from that, it's just a binary tree. Okay. While you do that reshuffling based upon what value you have inserted or what value you have deleted, that is what we call as heapify function. Heapify function. Okay, it's very hard to write it with cursor, but anyways, this is what you call as heapify function. This is what heap is. Okay. Why it is useful in our case, and why did I say that reshuffle part? It depends on what type of heap you have created. Have you created a max heap or have you created a min heap? Max heap means my largest element will remain at the root. My min heap means smallest element will remain at the root. Here I'm talking about max heap first, then I'll go to min heap. So I got these three elements. Let's see how a max heap will be constructed out of it. So when you take the first element 1, the one element will be inserted at the root and that is the highest so far. Agree? Agree? Okay. Now I pick up the next element. Next element is 5. 5 is greater than 1. Agree? 5 is greater than 1. So 100% sure this 1 cannot stay at the root because the rule of max heap is that your root will be pointing to the highest value. So after you got, so I will write like this. Once you have 1, it was this. Once you got 1 and 5, it will be like this. Your 5 will be pointing at the root now. Your 1 would be reshuffled here. Everybody clear? Everybody clear? We just inserted two elements 1 and 5. Since it is a max heap, so the highest element will put on the top and it will reshuffle the lower values down. Okay. Now we got the last element, which is 2. So once you have 1, 5, and 2, now what will happen? If you have 1, 5, and 2, 5 will still remain at the highest because that is the highest value. It will remain root. You already had 1 here, and now you will get 2 here. This is going to be my structure of max heap. This part crystal clear to all? I'm coming there. If element is 5 to 1, still the same case. 5 to 1 also my heap will look the exactly same. Nothing will change. Okay. All right. This is for the insertion part. Let's talk a bit of deletion also. If at this moment I say heap.pop, doesn't matter, left child, right child, doesn't matter. See, both the childs are same. It's not like it has to be a left child or right child. They both are at the same level. Okay. All right. Now, if you have to do heap.pop, the moment you do heap.pop, what will happen is the root element or the top element will be deleted. If you do heap.pop, 5 will be deleted. And then you will have a structure 2 and then 1. All agree with this? My 2 will become root and then you will have 1 on the left child. Come on guys, click in the chat. Everybody crystal clear, the max heap. This is max heap, okay? Which you also call as priority queue. So whenever you call, yes, because 2 is now the greatest, right? When 5 is deleted, you have only 2 element 1 and 2. So 2 is the greatest, that's what will become the root element. Okay. This is what you call as priority queue, but it's important to know when you say priority queue, it's internally what you're calling as heap. Now it can be max heap or min heap depending upon how you're defining the priority queue. Okay. Max heap part crystal clear to all. Okay. Now another thing to talk about here, which is interesting, I can go into the details of it, but it's good to know. If you want to go in details, feel free to go in details. Whenever you are inserting or deleting an element, something else is also happening. See, if I talk about just a binary tree and I'm inserting at a particular place without traversing it, complexity would be big of 1. If I'm traversing it, complexity would be big of n. Here, what I'm doing is I'm traversing. Without traversal, I'm inserting a value or deleting a value. The moment I insert it, there is a reshuffling happening. Agree? This 1 went down, this 5 go up, there's a reshuffling happening. This heapify function, the complexity is big of log of n. Okay. This is big of log of n. N is the number of elements in the heap. So if it is k, it will become big of log of k. If my heap contains n elements, heapify function, which is to shuffle the values, which will take log of n. Ideally speaking, when you say pq.add, pq.top is big of 1 for sure because you're not doing any reshuffling. But when you say pq.offer or pq.add, that is when this log of n is called. Okay. So in practice, people call it a big of 1 because I'm just adding an element, but it's not just adding an element. You're shuffling the heap internally. So every time you insert, every time you delete, one moment, guys. Every time you insert, every time you delete, the complexity is going to be big of log of n. Everybody crystal clear with this? PQ is priority queue, yes. Every time you insert, every time you delete, complexity would be big of log of n. N is the number of elements there. So if I inserted k elements, what is my complexity? Come on, guys, quick in the chat. If I inserted k elements in my priority queue, what is my complexity? Quick in the chat. Be quick, guys. This should not take this much of time. Correct. So if you inserted k elements, so k number of times you have done the insertion, number of elements are k only, so it would be k log k, not k log n. Okay. All right. Let me clear this up. Now let me go to the min heap part. Whatever we discuss in the case of max heap, exactly opposite will happen in the case of min heap. Okay. Min heap, I'm going to take the same element 1, 5, and 2. So what does min heap do is smallest element remains at the root. So 1 is going to remain at the root. If I take the first element, next element I got 5. 5 is less than 1, so 5 will come here. My root will not change. Next element you got 2, 2 will come here. Again, whenever you're inserting, whenever you're deleting, reshuffling may or may not happen. That's why we say the complexity is log of 2. Okay. Now, this is for the insertion part. When we talk about the deletion part, what would happen? If I say heap.pop here, heap.pop here. If you pop here, my 1 will be deleted. So if your 1 will be deleted, now you will have 2 as the root and then 5 to it. All agree? Come on, guys, quick in the chat. All agree? Cool. If this part is good, let me take next part. This is about your max heap and min heap. Let me clear this. Let me come back here. All right. So if I talk about priority queue, which is a min heap, my root will be 1, 2, and 5. Here, my root will be pointing to 5, 2, and 1. Okay. Now, who defined or who decide what is a min heap or max heap? Technically, you define it. Okay. But who decides whether the priority queue is max heap or min heap? Language decides it. You don't decide that. Okay. C++ priority queue is max heap by default. Okay. You can create a priority queue which is min heap. You can similarly in Java, you can do it. But I'm telling you, whenever you create a priority queue in C++, by default, it's a max heap. In Java and Python, whenever you define a priority queue, it's a min heap by default. It's a min heap by default. Okay. So if I take my values as 1, 5, 2, 3, 4, let's say, My max heap would contain what? It will contain 5, 4, 3, 2, 1 with my root or my top pointing it to 5. If I talk about main heap, it will be 1, 2, 3, 4, 5 with my root or top pointing to 1. And whenever I talk about heapify function, if there are k elements, let's put it as k elements in the heap, to readjust the heap whenever new element is added / removed, what is going to happen? Heapify function is going to be called. So my time complexity becomes, in that case, big of log k. Space computing big of k. Because you have k elements. Everybody crystal clear so far? Come on guys, quick in the chat. Everybody crystal clear so far? All right. Easy? Cool. If this is good, let's move on to the solution 3 and solution part. Sort that array log k will be complexity. What do you mean by sort that array? No, k is the number of times. Okay. This is for one heapify. If you're doing it k times, it will become k log k. If you're doing it for n times, it will become n log k. Okay. Log of k or log of n is the number of elements there. Sort the array log k will be complexity. It's not about sorting the array. I'm writing it because I'm not creating a visual diagram for it, right? That's why I'm writing it like this. Technically, it's not sorting an array. It's a binary tree. Okay. All right. If that is good, let's move on to solution for this. Solution 3 and solution 4. Max heap and min heap. So if my heap, if I'm talking about a max heap solution here for this question, if it is a max heap, my largest element will be at the root. So if a largest element is at the root, the approach is pretty straightforward. To sort with this technique, complexity will be unlocking. We are not sorting anything, understand? There's a difference between an array, there's a difference between a heap, right? What we are talking about is, if I need the top element, right? If I need the top element, that comes as big of 1. How internally I'm changing is, that is, if my heap contains k elements, I do n number of times, then it is n into log of k. Okay. If you just want to see like I can get the topmost answer, and if that's way what you want to call as descending sort, ascending sort, then yes, n log k. That's what if you're referring to. Okay. All right. Coming to this, if it is a max heap, my largest element is going to be at the root. So my straightforward approach can be, I can pop for k minus 1 times, then my root or my top would be pointing at kth largest element. Then accessing the top or head is going to be big of 1 time complexity. All agree with this first. If it's a max heap, it's a straightforward solution because your largest element is pointing at root. So if I pop k minus 1 times, I remove the k minus 1 largest value. Now the kth largest value is pointing at the top. So I can simply do pq.top. All agree? Come on guys, quick in the chat. Anybody has any doubts, any questions? Cool. Okay. Now, if I talk about the min heap solution, what do we need for do min heap solution? Min heap solution, my smallest element would be at root. So if my smallest element is at root, I need to pop n minus k times. It's exactly same as where we discussed in terms of ascending array and descending array. So look at this. In ascending array, you are talking about index of n minus k. you're popping about n minus k. In descending array, you're talking about index of k minus 1. In this max heap, you are doing pop k minus 1. Same thing. All agree with this? Come on, guys, click in the chat. All good? Cool. If that is good, now let's talk about the code part of each one of them. So first we'll see the code of max heap, then we'll see the code of main heap. So let me take you to lead code. Let's start writing the code for this. Okay. This is a main heap code. Let's start with the max heap code first, and then we'll talk about the main heap code. So I'll take you guys to C++ first. Okay. I'll take this guy. Or even better, let's compile and run it. Would be easy. Okay. Cool. Have a look at this code. Let me see if there is any pending comments. Nope, all good. Cool. Let's have a look at this code. What this code is doing is you have to find the kth largest element. You are given vector integer nums integer k. What did I tell you? By default, the priority queue in C++ is a max heap. By default, it is a max heap. Okay. If you want to make it a min heap, you can do it. How you can do a min heap? You can do something like this. You can just use the word greater integer. This will make it a min heap. Okay. But let's keep the by default one because we're talking about solution 3, which is max heap. So if I keep a max heap here, I inserted all the values in the array, right? So I create a heap with inserting all the values in the array. Now what do I need to do is I need to pop only for k minus 1 time. So I run a loop I equal to 0, I less than k minus 1, I plus plus. I do pq.pop. After this part, k minus 1 elements have been deleted. Now the kth largest element will be pointing at the top. So I can do pq.top. 1, 2, 3. Simple 3 lines of code. All agree? Create a max heap, pop k minus 1, return the pq.top. Anybody has any doubts, any questions, let me know. Everybody clear? Yes. See, priority queue is always a heap. Whether it's a min heap or max heap, it depends on the language implementation. That's what I was saying. In C++, by default, priority queue is a max heap. You can make it a min heap by writing this logic here, okay, which we'll talk about in the next solution. Similarly, in Java and Python, one moment. In JavaScript also behaves the same as Python. Yeah, in JavaScript, you don't have any such thing called priority queue class. You have to implement a max heap by using a class interface. Okay, so define a class. Inside the class, you would define a priority queue. Okay, you'll give the elements the priority and accordingly you'll implement. So queue can be implemented by a stack, can be implemented by queue, so on and so forth. Okay. But anyways, coming to the languages which does provide priority queue, let's talk about that. In C++, by default, it's max heap. In Java and Python, by default, it's min heap. Okay. So max heap based code, you just pop k minus 1 times. One moment. Max heap based code, you pop k minus 1 times, and then you do pq.top. Okay. Sort a minus b, simulate min heap, heap.length, smallest. What you're doing is implementing by an array, which is constant of heap. Yes, you can do that. You can implement by array, you can implement by stack, you can implement by queue. Okay. Practical can be implemented in multiple ways. But anyways, everybody crystal clear with this code first. Come on, guys, quick in the chat. We have to talk about other codes as well. Okay. If this is good, talk. Tell me about the time and space complexity. Quick in the chat. Tell me about the time and space complexity of the code. K log K, big of 1. Come on, guys, quick in the chat. Time and space complexity of this code. 3 lines of code, real quick. K log K, big of K. Okay. And log n plus K, big of n. Okay. Quick, guys. Anybody else? Let's compile the code. Let's submit it. K log K, big of n. And log n, big of n. K log K. Let's submit. 30 millisecond. Quite high. But anyways, let's check it. Complexity is what? Complexity is n log K. So none of you were correct actually, but let's see. I'm pretty sure it's not analog K. They have not made it properly, but anyways. See what is happening. Line number 39 is where pretty much all of your complexity would go in. What you're trying to do is, in this, you're creating a priority queue by putting all the values of the array. N values we have inserted in your priority queue. N values we have inserted in your priority queue. So space complexity becomes big of n, for sure. All agree? Whether they have calculated this, they have not calculated this correctly. Anyways, it's a bug. So my space complexity is definitely big of n because I've inserted all the n elements. Agree? Okay. Now, here what I'm doing is I'm popping k minus 1 time. So you can pop as many elements you want, but when we talk about space complexity, we talk about what is the maximum space you occupied. You already occupied the maximum space of big of n. Time complexity is important here. For one operation, insert or delete, let's talk about insert in general, you are going to do the heapify. So if my heap contains k elements, you're going to do big of log k, right? Here I'm inserting all the n values. So if I'm inserting all the n values, it's going to be n log n. My complexity would be n log n because I inserted all the n values together, right? After that, you're going k minus 1 time. pq dot pop is a big of 1 operation, no doubt. My total complexity will become big of n log n plus big of k. This is also big of 1. This part clear to all? N log n plus big of k minus 1 because of the for loop. N log n because I inserted all the n elements together. Space complexity remains big of n. Everybody crystal clear with this? Cool. Let's take this piece of code. I'll take this. I'll go back to Sublime Text and I will paste this number. Okay. Solution 4. What if we have to do one moment? Let me explain one more time. Removing will also be, so won't the second part will be k log n. I mean, in terms of n log n, k log n will not matter, right? pq dot pop will also do the reshuffling, no doubt about it. Once you already got n greater than k, so it doesn't matter if you put the k log n. Okay. All right. Coming to this part, what I was saying is here you put all the elements together. Just because I pass nums dot begin nums dot end doesn't make think that my complexity will be reduced. I can write a for loop. Inside the for loop, I can do pq dot add. Complexity will still be the same. I just put it in one line. That's it. What you did is last part of line 595 is you inside your priority queue, which was initially empty, you inserted the n elements. N elements, n times of shuffling. That's why the complexity becomes n log n. This part clear? You inserted an elements and time shuffling. That's why n log n. And then you're doing k minus 1. So plus k minus 1. Space complete big of n. Okay. Now, when we talk about min heap, in terms of min heap, what do I need to do? We already discussed in terms of min heap, smallest element will be at the root. So I just need to pop n minus k times. So let's have a look at that code as well. We'll continue with the C++ code. Then we'll go back to Java code because we started with C++ code here. So I'm going to comment this guy. Okay. Let's talk about solution 4. Here I'm going to implement a max heap. How to implement a max heap? To implement a max heap, you just need to add this parameter. The moment you add this parameter, it reverses the priority queue. That's all it does. Same thing is there in Java, same thing is there in Python as well. Okay. Now, once I got a min heap, what I'm doing is integer value in nums, I'm pushing into the heap. I'm putting a check. If my size becomes greater than k, I do pq.pop. Okay. pq.push, big of one operation, pq.pop, it will be calling a heapify whenever you are changing, and then you're telling pq.top, again big of one operation. Now, understand this. What is the maximum size of element I'm containing in my priority queue here? What is the maximum size of element I'm containing in my priority queue at one instance? You put a condition, if priority queue size becomes greater than k, start popping. Means you will not let more than k elements stay at one time in the heap. All agree? this code will not let more than k elements in my main heap. So I'm keeping big of k such. So my space quantity becomes big of k. All agree? My space quantity becomes big of k. Okay. Now coming to this part of operation. N number of times you're trying to run this loop, which you will run this loop for sure. But inside this n number of times, you're going to insert only k elements. So if inserting only k elements or deleting only k elements, whatever it is, it's going to do heapify function only k times. So my complexity will become n into log of k. Okay, so time constant becomes n into log of k, space complexity becomes big of k. So if you compile it, submit it, let's do real quick. Now my time complexity is n log k, which is correct, and my space complexity is big of k, which is correct as well. Okay. All right. That being said, this was your main heap code. Let's move here. Let's move here. Okay. So time complexity big of n log k, space complexity big of k. Easy. Cool. Now what next? Let's do the code in Java and Python as well. So I'll take you to other languages code. Let's talk about Java. In Java, we have a by default main heap, so I don't need to do any greater integer here. This is priority queue integer, priority queue. This is a main heap by default. What I'm doing here, exactly same piece of code, whatever I've done in C++. I equal to 0 or less than n, pq.add, pq.size greater than k, just to pq.pol. Complete remain comes n into log of k, space complete big of k. Run it, submit it. N into log of k, space is big of k. Exactly the same code, nothing would change literally. If I go here, put it back here, this is your code. Okay. Line by line, it's same as what we written in C++. All right, let's move on to the Python version. Will there be a chance interview will not ask about using priority queue? No. I mean, the expectation here is you'll solve by heap. Priority queue is heap. Okay. All right, let's move on to Python code as well. So in terms of Python code, there are two ways you can do it. I'm giving you both the solution. This is the way that I have done in C++ and Java. You can write it the same way. You can have a main heap. This is how you create a main heap in, by the way. And from that main heap, you can see length becomes less than k, then you're doing the push. Otherwise, you're keeping the first element, which is root here, and then you're doing main heap 0. Or if you don't want to, there's only one line of code that you can write here. This one line of code is doing what? This is priority queue. It's finding the largest element, k nums of -1. So kth largest element it is finding here. Okay. One moment. There you go. You can write this one-liner if you want to. I would not recommend one-liner code in interviews because pretty much it's using this internal function, which I don't think is a good way to explain an interview. So if you want a long answer, you can continue with this guy. This is a long answer. Okay. There you go. Time const remains the same. Analog k, space const big of k. Yeah. All right. Let me answer your question. pq.poll when size is greater than k. See, I want to keep only k elements here. Okay. I want to keep only k elements here. Since it is my min heap, what I'm going to do is I need only k elements so that I can return the kth largest element on the top. So whenever the size becomes greater than k, that is when I'm doing pq.pop. Okay. Whenever my size becomes greater than k, that's why I'm doing pq.call. Good. All right, guys. pq.pol is pq.remove in C++. All right, guys, that was a really good question. We talked about all the four solutions in detail. Again, repeating, the expected solutions are solution 3 and solution 4. Ideally speaking, the expected answer is you will be able to solve it n log k. Okay, space comp big of k. And you should know the clear basics of what a heap is and how a heap works, those kind of things. Okay. Again, goes without saying, kth largest element is asked. The question can be converted, written with the index of kth largest element. The question can be asked like, give me the kth smallest element. So in kth smallest element, a complexity will still remains big of n log k. Complexity will become big of k. The only thing is, one moment. The only thing is, in terms of kth smallest element, the most optimized approach will be given by max heap. In case of kth largest element, it's given by the min heap. All agree? One moment, guys. I'll answer the question. Everybody clear? In K, the four solution that we discussed, the most optimized solution was solution 4, which is n log k space big of k, which is min heap. And in terms of, I'm repeating it. The question for kth largest element, the most optimized solution is given by the min heap. All agree? N log k space big of k. All agree? The most optimized solution is given by the min heap, which is n log k and space big of k. Correct? If the question changes to smallest element, then it will be max heap. Again, n log k space big of k. You have to do the same thing, just do in reverse order. So max heap. Okay. I'm talking about the variation becomes k at smallest element. To your question that you asked, optimized solution is sorting approach causes space complexity. No. See, whenever we talk about optimized solution, we mostly stick to time complexity. Space, we do not bother much because we have multiple hardware devices to take care of it. Time is something we do not have, right? So time complexity is the critical deciding factor whenever we talk about optimized solution. Okay. All right, guys. If that is good, let's quickly revise what we have done as part of today's session. Then we'll continue with next part. Yeah. See, it's the other way around. Heap is not implemented using priority queue. Priority queue is implemented by heap. That's the right term to use. Okay. By default, it's max heap or min heap, depends on the language. Yes, you can define heap by your own classes and interfaces. You can define it by array. You can define it by stack. You can define it by queue as well. Okay. The statement heap is implemented by priority queue is incorrect. Priority queue is implemented by heap is the correct statement. Okay. And yes, there are other ways which I just mentioned. All right, guys, quickly revising what we discussed as part of today's session. We started with sorting, which is an algorithm which is used to convert unsorted list of values to sorted list of values. I've given you one homework question. Feel free to give me an answer tomorrow. Then we'll discuss it. Just putting it in the chat. We first talked about inbuilt sort, which works in n log n and space comp big of 1. We very clearly identified it cannot be a just quick sort. It cannot be a just merge sort. Okay. Quick sort because of time complexity, merge sort because of the space. So what is it exactly? It's actually a hybrid sort. Hybrid sort means combination of multiple sorting. So in Java and Python, it is stem sort, combination of merge sort and insertion sort. In C++, it is quick sort, merge sort, insertion sort. There's no name as stem sort in general in C++. Okay. Then we deep dive into the different sorting algorithms. We start with bubble sort. We talked about how bubble sort work, why it is called name as bubble sort, time complexity, code, big of n square space big of 1. We talked about best case and worst case scenarios for bubble sort. Then we talked about selection sort. How it is the approach of selection sort. We did a dry run to understand that better. Time comes to big of n square space big of 1 and approach where it is opposite of bubble sort. Okay. Then we move to lead code 215, the first question and a very important question, kth largest element in an array. Okay. So first thing first, kth largest element versus kth largest unique element. These are two different questions. This is kth largest element, not the unique one. One way is you can simply do ascending sorting, return array of n minus k, n log n space big of 1. Second, you can do descending sorting and return k minus 1, n log n space big of 1. But that is not the optimized solution. Optimized solution is via heap. Okay. To understand what is heap and how does heap work, we talked about the diagrams, we got different languages implementation, how does min heap work, how does max heap work, so on and so forth. Okay. We talked about the complexity of heapify function, how does it work, so on and so forth. And then we finally implemented solution 3, which using max heap. And then we implement solution using min heap as well. Okay, we implemented in multiple languages as well, passed all test cases, and that is our expected solution. As I said, anybody with more than 5 years of experience, it doesn't make sense to ask merge or quick sort, at least in the large product-based company, they would not ask it. I mean, depends on the interview, depends on the role, they may or may not ask it. But I do not expect it to ask, but be well prepared with the code. Okay, that's what I would say. What do we need if we need to distinct element? Think. Let me know if you're not able to think about it. What separates a distinct element from non-distinct elements? Just create a set out of it and you'll get the distinct elements. Okay. All right, guys. Any more questions? Any more questions? All good? If everything is good, let's wrap up the session here for today. Let's catch up in the next session and then we'll resume it for tomorrow. Okay. We'll continue with our sorting questions and some of the theory and then we'll resume from tomorrow. Thanks for joining in. Have a good one.